Hey guys, welcome to another episode of the Mind Muscle Connection podcast. And today I have a very special guest, Dr. Brandon Roberts. He's a captain serving in the U.S. Army as a research physiologist in the Military Performance Division. He's also he has a bachelor's of science in microbiology, MS in human performance, and a Ph.D. in muscle biology, all from the University of Florida. And as we talked about off air, he's also a writer for the Weightology Research Review. So, Dr. Brandon Roberts, thank you for coming on today.
Yeah, thanks for having me, Jeff. I appreciate it. I've been listening to your podcast for a little bit, and you got some good guests coming on. And I was like, let me get in on that.
Yeah, that's awesome. I appreciate that. If we have people like you listening, that we're doing much better than I thought we were doing. So that's good to hear. But yeah, was there anything I had missed in the intro there?
Not really. I think I've kind of had some experience. Like a lot of people think of me as a straight scientist, but I've had some experience in the strength and conditioning world and in the personal training world, and was an online coach for quite a while with the strength guys, and then with Macros Inc. for a while longer. So I do provide the one other thing that didn't mention is I'm a kind of chief science advisor for tailored coaching method. So basically, I just help the trainers understand science, and it's a lot of what I normally do for, like, if you follow me on any social media. So that's the other big thing that I do. Yeah.
Cool. Yeah, tailored coaching method. We had Cody Roberts, Cody McBroom on a couple weeks ago, and yeah, he's a super smart guy, and that business is growing. And yeah, it was really cool to hear that you are the chief science officer there, and that seems like a pretty cool role. So you're just kind of teaching the trainers like the science behind things, and just kind of, I guess, furthering their knowledge essentially.
Yeah. So it's like continuing education stuff, right? Because science comes out fairly frequently. Maybe not. You get a whole lot of data on like hypertrophy at one time, but if you add in the nutrition and the training and then the different diets and it's a lot to take in. So I basically kind of boil that down, interpret it, and then kind of give it to the coaches in a applicable way so they can apply it to their clients. For example, our next con ed, I don't even think they know this yet, but our next con ed is going to be on kind of eating pathologies. So like um, how to tell when your clients are maybe struggling with some eating disorders or things like that. There are a couple scientific questionnaires you can give, super simple, to just give you some insight. Like, hey, should I be worried about this? This person, what do you think? And that's what I try to do, is just help people understand other people.
Yeah, that's really cool. And I know that you do that obviously with Weightology too, right? I mean, that's the main thing with Weightology is like, I do enjoy the science side of things, but it's hard for me to really dive into it and like dissect it like you do. And you guys at Weightology, Mass, like you guys all do a great job of breaking it down and making it understandable for coaches so we can apply it to our clients. And I think it's great. That's something that you don't think about, that there would ever be like a like role for that, but there is. And it's awesome. I think it's great. And obviously, like we talked about off air, we're going to talk about a few of those papers that you wrote for Weightology. And so I guess, as far as you said you used to coach, is there any more coaching, or is it mostly just this is what you're doing now, just kind of breaking down the science? And I guess too, are you doing any research right now as well yourself?
Yeah, so I had to give up time commitments, right? You only got so much piece of the pie. So I had to give up coaching. And, if you've coached a couple hundred athletes, let's say, you kind of understand what the problems are and the issues. And I try not to get too far away from the client. So I do a lot of interactions with the coaches, like one-on-one troubleshooting some of their clients. So I don't coach technically, but I'm involved in coaching. I was actually called at the NSCA conference recently. Somebody was like, "You're a pracademic," and I'm like, "What is that?" They're like, "Well, a practical academic," and I'm like, "Okay, I guess so." I mean, yeah. So I think that explains my role fairly well in terms of kind of current research. So always busy, always have a lot of projects going on. I try to diversify my portfolio as much as I can because things get hung up in different processes or different steps of, like, data collection or participants just not having them, like during COVID, for example, or peer review or getting a grant, things like that. So I kind of have things that I'm semi involved in. So applicable to our discussion later, I'm part of a study with Eric Helms, James Krieger, and Brad Eater on bulking, right? And so it got interrupted by COVID. But basically, what we did or what we're doing is comparing two different weight gain percentages and seeing if that allows more muscle mass or how the fat mass to muscle mass ratio is occurring over, I think it's like 10 weeks. So not too long, but kind of in lines with something you would actually do. And our percentages were like 0.5% body weight per gain per week. And I think it was 1.5. So like I have studies I'm kind of part of. There's another study with Jackson Pios on his series of kind of reverse dieting or diet breaks, not reverse dieting, diet breaks. And so we have a follow up on that, looking at like if you use diet breaks over this long period of dieting, what happens on the end in that last week when you stop dieting. So we got a paper coming out on that in I think 6 months or so. So that's kind of like the tangential stuff. Um, in terms of my lab, we're studying how NSAIDs, so ibuprofen, some of the prescribed NSAIDs are like celecoxib, flurbiprofen, how those influence skeletal muscle and bone during training or just during baseline conditions. So that's kind of what I'm focused on now, but I try to, again, stay diversified.
Cool. Yeah, that's awesome. I know that. So I went to the ISSN conference and I heard your talk on the NSAIDs, and I thought that was really interesting. And I honestly didn't. I didn't know that you had worked with the U.S. Army. That was, I didn't know you do research there, and it's kind of weird to think that they do that type of research, honestly. But I mean, it makes sense though. I mean, it's needed obviously to further that and make them better. And yeah, I found the NSAID talk very very interesting. And so you're continuing to, I guess, look into that even more then.
Yeah, yeah. So basically, our goal is to try to tease out which NSAIDs, because they all have slightly different mechanisms, are beneficial or detrimental. So there's a good bit of data if you've kind of been following the NSAID research to suggest if you take a high dose of NSAIDs after training or mostly before training, you can kind of mitigate or stop some of the beneficial adaptations like muscle protein synthesis, which over long term might be, muscle growth, right? Uh, so the trapeze have some data on that. And there's a couple other studies, but you know, there's some nuance to it because a lot of the studies use very high dosages, and when you use a high dosage, it's great because you can show something, right? Like you're more likely to show a change, which in science matters. But as a athlete, I'm not going to take the whole dosage for the day of my NSAID right before training. Like if I'm going to take it, I might take one pill, so like a third of the recommended dose for the day. And maybe afterwards or later in the afternoon, I take something else if I train in the morning. But I'm rarely kind of pushing that maximal dosage. But again, some athletes do, especially in endurance athletes. The triathlon athletes like to really kind of push their dosages up. If you're in a military perspective, if you're in camp, right, you're trying to make it through 9 weeks or 6 weeks or whatever it is, um, you kind of just have to make it, right? So then you're like, well, I don't know much about NSAIDs, but they make me feel better, right? If you're younger, you maybe don't know science much. So I'm going to take them so I can get through this. So yeah, that's the kind of rationale of what and why we're doing research on insects specifically.
Yeah, that's really cool and interesting too, because I think a lot of people do take NSAIDs and they don't really think about that, right? Like you said, it's just, somebody like that's in the army like that, they're just trying to get through camp, the basic training, and they don't really care. They're just trying to get through it, right? But then even athletes too, like you said, they probably take this stuff regularly and not realizing that it could be hurting muscle gain. So I think that's really important there. And I'm curious too to hear about, um, I know kind of your takeaway there from the NSAIDs was, take it if you need it, but don't necessarily, if you don't really need it, it's probably not going to be beneficial. Correct? Was that kind of the main takeaway from the NSAIDs there?
Yeah, yeah, and I think there's a little more science that it might hurt your bone recovery more than the muscle recovery, because muscles are pretty plastic, right? Like you can train, you can stop training, muscle changes in size and strength, and you get a lot of quick changes with muscle, but bone turnover takes like 3 months at least. So if it's hurting bone development and recovery, that could be more detrimental. So I was kind of, we're leaning on the bone stuff, but my expertise and my interest is in the muscle stuff.
Right. Yeah. I'm sure as you do some of this research, like you have an idea what's going to happen and then something interesting pops up and then now you're like, okay, now I want to go kind of see what's going on there with that too, right?
Yeah, yeah, definitely. It's like research leads to more research, leads to more questions.
That's good though. That's what we want. That's the ultimate goal
Yeah,
of it. And
yeah.
so, yeah, again, kind of with the army, is there any other type of like interesting stuff that you do there? Like, are you like the main person there with the research on that side of things, or is there like a whole team, or what does that look like?
Yeah, so there's a whole like group of scientists, military and civilian, that kind of work together, um, and we study everything from performance, like return to duty, so injury recovery. We study. We have a whole division of like, I think there's like 30 or 40 people in this division for just nutrition, right? So like fueling the athlete in different environments during operations when you may not have ideal situations, or you have a lot of stress. Um, then we have a whole division again on the thermoregulatory division, where they just look at extreme environments, and how we respond to like heat stress, right? So if we're in Afghanistan or Iraq, we need to be able to adapt to hot weather. So how do we deal with that? Uh, on the reverse end, cold weather too, like Antarctica, Alaska. Um, how do we adapt to those situations, and what can we do to better perform or just survive sometimes in those? And they also have some like high altitude stuff, some subterranean stuff, so like underground. Um, yeah, so we like pretty much any aspect of, I would say, performance and kind of anything dealing with that, we do. And it's not always public, which doesn't mean it's like top secret. It just means that sometimes we do stuff for us and nobody else really cares.
Right. We do it for us. No one else cares about it. Yeah. I'm curious, are those studies like, obviously, I mean, they have to be super helpful, especially for when, like you said, you're in Afghanistan and under these like extreme conditions that you're not normally in. How is the how like is it, I guess, do you guys do the studies when people are in like boot camp, or what does that look like? Like, how do you perform these studies? Because to me that would be probably the biggest challenge there, is trying to figure out how to actually like conduct the studies.
Yeah, yeah, and that was coming from traditional academic setting. That was also my questions, like how do you do this? Like, because they're very similar to athletes in that the coaches, which is like their instructors or their commanders, may not understand or even like want you to be involved if you don't like clearly say, hey, this is what we're doing, this is why we should do it. Can you let us borrow carefully your soldiers to do some kind of study so that we can help them later or future soldiers. So we have a couple studies in like basic training, which is just a 9 week thing where so you sign up, you enlist, you go off to camp, boot camp, basically is what they call it. 9 weeks, you get kind of trained up, and so we have a study kind of looking at different outcomes in that. Um, Mainly, we have a problem with a little bit of a problem with stress fractures. So we want to avoid those, right? Because stress fractures are bad. Um, and so we're trying to figure out what's involved and why does that happen. So that's in the basic combat. In kind of the later camp, so you go to basic training after you enlist, and then you go to something called AIT, which is kind of your job specific training. And that varies from, like, I think the shortest one's like 6 weeks, and the longest one's like, if you want to be a helicopter pilot, for example, like 2 years. Um, so you have this huge branch, and we don't study them so much. I'd like to a little bit, just because it's more structured. It's a lot like, not college, but I mean it is kind of like college, like a stricter college, right? Where like you have to do your classwork, but you also have to go do PT, and you also have to do like military training, right? So go to the range, learn how to navigate, things like that. Um, so we try to use those populations. We can't always. Sometimes we'll find like an infantry unit, right? Who it's like, hey, we want to test if this new boot works, right? And you guys march a lot because that's what you have to do. Can we use you and like test this stuff? And sometimes they're okay with it, sometimes they're not. I think the higher up you go, so like the special forces guys, um, the less risky stuff you can do, just because like at that point you're working with super elite athletes. Like they're so fast, big and strong. It's insane, and they can undergo a lot of stress. So for them, it's like, okay, you want to give me this drug. So for example, there's a study that was published not too long ago, um, on testosterone injections during operations, and it was like, I think it was like 100 milligrams per week, so not much. Um, and the idea was like, these people are under stress. If we give them testosterone, maybe it'll help them. Well, it didn't do a whole lot. So there's a follow up study with more testosterone, but it's hard to say like, is it going to be beneficial? And a lot of these soldiers don't want to risk it. And frankly, I don't think that, like, if I'm going to be an Army Ranger, like, I don't really necessarily want you studying me all the time. Maybe during training when it's not, risky, but not during like Ranger school. No.
Yeah, it's you mentioned like these more, and I'm sure that that's probably the issue with most research when it comes to like performance and stuff like that. The most elite ones, it's going to be very tough to get them to do anything because they know it works for them and they don't want you to really mess with that. So I'm assuming that's probably the biggest issue there is. But in saying that, you probably that's a population that we probably want to get a little bit more research on too. I'm sure, right? These more advanced
Yeah,
people.
yeah, yeah, definitely. Especially like figuring out how, why and how they are so advanced, right? So we haven't done this yet, but I'd like to do it sometime in the future. Look at the genetic component, right? Like how much of it is in their genes and how much of it is, in their head. And they're linked, obviously, but just because you're genetically predisposed to being like a super athlete doesn't mean that you are necessarily.
Right. Yeah. How big of a role do genetics play in that? So I guess one more question on this side of things. So what's been like the most interesting finding, one or two most interesting findings from doing research here in the U.S. Army that like you've been like, oh wow, that's crazy. It kind of changed your mind on something. Is there anything that sticks out to you that you guys have found in the last little bit that's been pretty, interesting to you?
Okay, so I haven't been there long enough to find anything like super cool. I'll be honest. Um, but some of the older research on just like what people can go through, for example, like go back to Ranger School, where you have these guys who are for 60 days, they're in and out of the field, they're sleeping for like 3 hours a night, they're eating 1,200 calories a day, they're doing operations and stuff like that. And so just like what happens physiologically when you go through that is probably some of the coolest research to me. Not even like intervening yet, just be like, what can the body sustain and how long can it do it without, totally.
Right. Yeah. So what's like the craziest thing there with that? Like I'm assuming the body probably is pretty it can handle a lot of stress. I'm sure that you found by looking at stuff like that.
Yeah, yeah. So I mean, and it kind of relates to some of the bodybuilding and physique literature where, when you're under stress and you're low energy and you're working out, and there's more stress obviously in field operations, but your testosterone drops and your recovery is shot. And like, doesn't matter how much you eat, you can't recover. And so some of these training, like, schools you'll go to, and then you may not recover fully for like 6 or 8 weeks, and so it's akin to overtraining. It's not quite overtraining because it's not just like one sport or one, movement or something. Um, but yeah, it's just the body can withstand a lot of stress.
That's good to hear. But yeah, appreciate all the work you're doing there. That's awesome to hear, and it's just really really interesting stuff. I was again really intrigued by it when I found out you did research there. So cool. Thanks for sharing all that. So yeah, I guess we'll dive into the first paper that we had talked about, and the first one is, can we predict muscle gain while walking? And I think this is important to go over because think there's a lot of, we talk a lot about fat loss and things like that. And I think this is an interesting way to go because, there's not as much information on it for people, but it is very important, especially if you want to maximize your physique and build as much muscle as possible. We can save a lot of time probably by not, by not gaining too much body fat. And so, yeah, I think it's important to kind of talk about this and how much muscle we can gain when bulking. So I guess, yeah, kind of give a brief background on why you looked into it, and then we'll just kind of roll from there.
Yeah. So, like I said, there's not much research on it. The study specifically is Grant Tinsley's study, and he was basically giving people a supplement for 6 weeks, and he told them, hey, I want you to gain a pound a week, and here's a supplement, and we're just going to see what happens. There was no like control group. It was just we're going to increase your calories by giving you the supplement. We're going to take body composition really well because that's exactly what he does. It's like the body composition guru. And then we're going to look at all of these outcomes and see if we can predict, what the best gain rate is. Now, it didn't quite work out super well because I don't think he had enough people, but he did find some interesting data. So they gained, I think it was like 10 pounds or something over 6 weeks, which is a lot. um, is a lot, and their performance went up too, right? So when you eat more, you gain weight. If you're training consistently, your performance should increase. It's just um, how much it increases kind of varies a little bit between people. And the other thing that they did is, of course, they had lots of protein. They're eating plenty of protein, plenty of calories. Um, and so that was kind of the impetus of this study, was just trying to figure out like what happens when we overfeed people, and can we predict how they change or what's optimal.
Yeah, cool. And there's like, I know in the paper you had talked about, there was other research kind of done on this topic a little bit, right? Like there is some research done. Can you kind of give a little background on like what that's kind of pointed to?
Yeah. So there's a couple studies. There's a Rosenek et al. Or Rosenek from 2002, where they basically gave like 2,000 calorie weight gainer shakes, and these people were new to training. And I think when you're new to training, you have a lot more room for calories because you're growing more muscle more quickly. And they found that like more protein is better, and the calories, 2,000, they put on a little bit of fat, but it wasn't terrible. And so that study kind of said, hey, well, 2,000 might be kind of ridiculous, but if you're newer to training, you can surplus more. You can have a higher surplus. Maybe go 1,000 or something. I think I generally recommend like 600 to 700 calories a day, which is still pushing it. Uh, so then there's another study by Bray in 2012, which basically it was a protein comparison study, but they were overfeeding people. And this study actually led to the series by Jose Antonio, where if you use protein to overfeed people, it doesn't really get converted into fat. It's like too difficult or it's inefficient for the body to do. So that data kind of indicated that, hey, if you overfeed solely on protein, you can gain fat-free mass. And they weren't training, so it's hard to kind of bridge that gap. But if you couple that with the Antonio studies on overfeeding with protein, um, it looks like high protein is good, right? For surpluses in general. And then there was one other study by Spillane and Willoughby, and they gave protein shakes very similar to the Tinsley study. And they were like 1,600 calories. And they were trained people, and they gained about the same amount of like fat-free mass, or like your surrogate for muscle mass, as fat mass. And so that was, again, a lot of calories in trained people, but it kind of gave us some more insight like, hey, okay, we're getting closer. This is kind of, we need to be well below these 1,200 calorie shakes, 2,000 calorie shakes for trained people for sure. And we need to make sure we focus on high protein.
Cool. Yeah. And so one thing you mentioned there was the importance of trained and untrained. So I guess what's the importance there for that? I know you kind of hit on that briefly, but if you don't mind kind of talking again about the importance of it being trained versus untrained there.
Yeah. So uh, In the first year, so say you start training and you've never trained before. The first year, most people, if you train, let's say 4 days a week, just doing a typical upper lower split, nothing fancy, just like 4 days a week, upper lower, you could gain 8 to 10 pounds of muscle, which is quite a lot, especially if you start like in high school when you're still kind of growing a little bit. Um, and then after that, every year after that, it kind of decreases. And we don't really know. I ask this question to a lot of people, and I myself, I still don't have a good response. How long does it take to build muscle, right? And we don't. There's no like one answer. It's over time. Every year you train, it gets harder. And so, as a physique athlete, right, you may gain muscle your first year. Well, then the next year is going to be like 6 to 7 if you're lucky. No injuries, of course. The next year is probably going to be like 3 to 4, and then from there it's just going to kind of like bottleneck at 1 or 2. Um, and past 6, 10 years, you're not seeing a whole lot. Like it appears that people get denser, which we haven't quite figured out. And that kind of lends to the sarcoplasmic versus myofibular hypertrophy. But we don't like, there's one paper on it, so I'm not sure if that's a big thing. But yeah, that's kind of how we understand muscle growth over time in different periods of like started training versus like you and I who have been training for a long time, right? So it's just very different.
Yeah, and so obviously the longer you train, the tougher it is to put on more muscle. And so I guess there with that, because to me, when you first think about it, it would make sense that like a higher surplus as you get more advanced would make more sense, but really that's opposite. And the big thing there, from what it sounds like, is when you're untrained, your body's gonna, it has more room to grow, and so it's almost going to utilize those calories a little bit better than
Yeah,
somebody who's more trained, essentially.
yeah, exactly. Like that's that. Yeah, that's what I think.
Yeah. And two, so I guess maybe take a step back. Why is being in a surplus important? Because I do think that that's important to go over too. Because, obviously a lot of people, well, okay, well, you know, do I have to necessarily bulk to build muscle? It's like if I'm worried about fat gain, why do I necessarily have to bulk and like, you know, eat in a surplus?
Yeah, yeah, and so for that first like year or two, if you're, I wouldn't recommend being in a deficit necessarily, but if you like eat your maintenance and just train, you'll gain almost probably equal muscle. Like there's not a large difference. I think it's maybe 10 to 20% difference, which if you're in a hurry, right, which most people are kind of in a hurry, they're like, oh, I want to gain muscle, I want to get bigger, yada yada. I'll take that extra fat for that faster muscle growth. Um, so I think, in the beginning, you don't really need to be in a surplus, but then as you age in training, your body is fighting it, right? Because it's metabolically costly to have muscle on you. Like it just takes a lot of uptake. You have to keep your muscles fresh, so protein turnover is going. That takes a lot of energy. It's kind of like an amino acid sink, so all the amino acids are kind of just sitting in your muscles. And so when you are trained, you need like a reason to grow. And part of that reason is your training. And then the other part of that reason is like these extra calories, right? So now you have a energy source and you have a stimulus and you combine those. And you're like, okay, body's like, well, I would rather use this to better adapt to my stimulus than save it in my fat cells so that I don't starve because I'm eating plenty.
Yeah. So essentially it's again, it you need to give the body a reason to build muscle.
Yep.
And it's, if you're not giving it enough food, it's obviously, it's like, well, this just doesn't make sense to build more muscle at this point. Awesome.
Yeah. Yeah.
Cool. Yeah. And so I guess too, with that study, I know that I believe the rate of gain, because the rate of gain they were looking at was what, 0.45 kilograms on that.
Yeah, so about a pound a week is they wanted people to basically gain a pound a week or more.
Okay. Gain a pound or a week or more. And with that, I know kind of the main takeaway from it was that you mentioned that seems to be a bit excessive for trained individuals, correct? They saw more fat gain than,
Yeah, yeah, they did. And I'm trying to pull up the exact numbers, but um yeah, I think it was quite a bit of fat. it was fat to the point where like a pound a week is probably too much for most of these people.
And
So
where we're looking at a pound per week, is that, are we talking like what's the surplus in that? Is it going to range, or is there like a number, like a calorie number there for that? Or
yeah, so they aim for 650, but kind of when I tell people to bulk, I give them like brackets, right? So it's like if you want to go, if you don't want to gain as much fat and you want to lean bulk, we'll call it, somewhere in the like 100 to 250 calories surplus per day, right? And you'll probably gain weight pretty slow if you kind of use the rule of 3,500 calories a pound, right? It takes a long time to get up to that 3,500 calories in 100 calorie increments or even 200 calorie increments. So that's the slow rate. And that's what, as you age, I would kind of recommend you do. And then as you go to say, let's say you're in the 250 to 500 calorie range, your ratio of muscle gain to fat gain declines. So, like in this study, they had a ratio of 1 pound, we'll call it, of muscle, they gained 2.5 pounds of fat, right? And you're like, well, okay, so I gained 3.5 pounds, and most of that was fat. Was it worth it? You're like, probably no. I could probably, reduce that fat mass. So that's what the kind of the takeaway is from the study, that maybe they just push too much calories. But again, I think it was a supplement study, or it was. So it's probably one of those times where the company comes to you and says, "Hey, will you test our product?" And they're like, "Yes. What can we do with this?" Because you have students and you have obligations to do research, and so this is what they decided to do.
interesting. Okay, I see. So it was they wanted to test out the. I'm assuming it was like a mass gainer type supplement, or what? Yeah.
Yeah. It doesn't actually say in there. I don't think it says the brand, because I probably would have put that in the review. But yeah, some kind of mass gainer or calorie. I mean, it could have been like a heavier protein shake, because it was not like a 1,200 calorie thing. It was only like 650.
Yeah, and I know a couple other things, like you mentioned that strength increased, size obviously increased, and then metabolic rate increased as well, right, during this?
Yeah. So when you gain weight in general, like fat or muscle, your metabolic rate will increase. And that's expected. Like you're carrying around more tissue, it requires more energy, so then the calories you need just to live increase. Um, the calories required for muscle are way higher than the calories required for extra fat. That said, like I think it's for every like kilo of muscle, it's still only like 25 extra calories a day. And for fat, it's like 5 calories a day. So it's not like you can gain, a couple pounds of muscle and be like, I can eat 500 more calories a day. Woohoo. Right. It's just like, it probably not even possible.
Yeah, that's a thing that, because I've heard this go back and forth there on that, where like, oh, if you have more muscle, you can burn more calories, which sounds like you can, but again, it's one of those things where you hear like, oh, if you eat more protein, you increase your metabolic rate, but it's like, yeah, it increases, but it's really not that much. But I'm sure that any little bit probably adds up, though. Somebody that is more muscular, it's going to add up over time. I feel like when you combine all these things in.
Yeah. And that's what I think some researchers, and I don't say they miss the idea, because they probably have thought of it, but research is finite. You have 6, 8, 10, 12 week studies. Sometimes you'll get like a year study if you're lucky. Like those are rare in kind of our population, because like why? Like nobody really cares. So it doesn't get funded, so you can't do it. But yeah, like if you think about all of these little things adding up over time, it probably does make a good difference that's noticeable over a year or 5 years. Definitely, the longer you do it, the better and more you'll probably notice. It'll just be incremental.
Right, because and that's a good point you bring up. These studies, when they say that, they're not these, like you said, year long studies, 5 year. We don't really know. Same thing with like the protein timing thing. I feel like we don't know how big of a difference that can make on like a really long term scale there. Which it's just tough to do. Like you can't, like you said, you can't do like 5 year studies. Well, you could, but it would just be very tough to do that and measure all that stuff, I'm sure. And then also, and this is more anecdote, but like I feel like I just feel like people that have more muscle, they're just able to like utilize the food much better too. And I'm assuming that that probably has something to do with just again you're burning a little bit more calories when you have more protein or more muscle. Um, but on the metabolic side of things too, is that something where when you increase calories, you also see things like NEAT increase as well? Is that something that you'll see go up as well?
Yeah. So what and this is a good example for coaches and scientists too, um, is the idea behind reverse dieting is what I tell my coaches is that you want to, as you increase your calories, you're looking to increase their movement. Because I'm a strong kind of not believer, but I think that more food and more movement, just normal movement, not like exercise, is just better for your overall health and long-term like sustainability. So like, and again, it's increments. So eating 2,000 calories and moving 2,000 steps a day is not as good as eating 2,500 calories and moving 10,000 steps a day, or whatever the ratios would be. So we call that like a high energy flux system. And I think in athletes, that's what they do. Like straight up, they eat a bunch, they train twice a day, they sleep a bunch. And the normal person doesn't always have time to do all of those things. But I think the more we can get, like the closer we get to that, the healthier and better you'll probably feel.
Yeah, I mean, like you mentioned, athletes. I mean, they 4,000 calories for some of them probably they can't even maintain their weight on that. Which you give most people 4,000 calories and they're going to be gaining a bunch of body fat. Um, cool. Yeah, and then obviously size. I mean, they grew muscle during this. That was the takeaway there is that they grew muscle, but the downside is that they just added extra body fat. Which again, I'm sure at that point you just need to ask yourself, like you said earlier, is it worth it to do this? And
Yeah. Good.
no, you can go ahead.
So yeah, like if you're let's say you're one of the people who is naturally lean, like, and you don't have a lot of fat or muscle, well then maybe you look better or you like how you look with 10 pounds extra with not like a little bit more of it being fat, right? So you have some variations. Whereas like I was a kind of a fat kid. So if I want to gain muscle, like I don't really want to put on any more fat. I already got a good amount of body fat on me, and so I probably wouldn't take that approach.
Right. Yeah. Somebody you just basically at that point. I mean, it's probably trial and error. But again, if you've had, like you said, if you grew up and you were a little bit larger when you were younger, like you're probably somebody that's not going to want to go and too much have a surplus because of that. You don't want to gain that excess fat there. And another thing that you mentioned that was really important was protein. I remember, I think I read in there where they did a study where it was like they it might have been that 2016 one with Willoughby where did they have a group that did not do high protein?
Yeah. So I think it was the Willoughby study where they had like 1 gram per kilogram of body weight, and then like 2.4, I think it was. So which is essentially adding a really big protein shake. Um, And so yeah, the high protein group did way better. So it's fairly well known that high protein is good. We don't know how high, right? Like the gram per pound of body weight is kind of the not max, but like the standard for physique and bodybuilding athletes. It's like just eat your body weight in protein. That's easy. Um, and we're not sure like how much more you can go over that if it's beneficial. The Antonio studies show that 3.4 grams per kilogram of body weight and 4.4 grams per kilogram of body weight are, useful, but those are small populations and single studies. So we have to kind of be careful. But that's the population that most of your listeners, your athletes, your trainers is those people who are training regularly, eating hopefully good regularly, and now they're like, do I go high protein or super high protein?
Right. Yeah. I mean, I'm when because I had Dr. Antonio on the podcast, and I know like he mentioned, when they go super high protein like that, a lot of it's just from protein shakes. Because I mean, asking people to get that much protein through like chicken or something like that's just insane. And I guess there at that point, it's like, I mean, all that protein powder, I'm sure at that point, then you need to see how that feels like on your stomach. Because if you're feeling like crap all the time, that's obviously going to hurt as well. So I'm sure that's something that you need to take into consideration there. And I personally, I don't know about you, but I think it sounds like there's a lot of benefit to going super high with protein, but like you said, after the 1 gram per pound of body weight, I'm sure from my understanding, there's not as much benefit if you're just trying to build muscle.
Yeah, yeah. And I think, it also varies on the population side because like now I don't train like a bodybuilder really anymore. Like I have to do a lot more endurance type stuff. So to push the protein high limits my carb intake and maybe my fat intake a little bit because I'm kind of staying in some calorie range. So like right now I'm probably at like 1.8 grams per kilogram, which is still within the like golden range, but it's not as high. So it always depends on your goals too, right? And pure endurance athletes can get away with even less. I think there's about 1.5 to 1.6 grams per kilogram of body weight. So you have some flexibility in there, and a lot of people get caught up with comparing themselves to bodybuilders, and that's hard to do.
No, you're 100% there. I mean, I feel like that's where a lot of the uh, a lot of people they take what they see and it's from like these professional bodybuilders, and it's like it's probably not exactly who you need to be following, right? So that's a good point you bring up there. And so I guess to kind of sum this one up, can you like speed up the muscle building process, or is it just something where you just kind of need to be patient with it? And you know again, as you advance, you want to be in a surplus, you're going to see some fat gain, but is there anything you can do like that we didn't talk about that can speed up that if you're taking a pound of weight that you gain, can you speed that up to get it to make it more lean body mass than body fat?
So I don't think so. I think finding the optimal training program for you like is probably the biggest thing you can do where you like recover but you're stressing enough. Like so for example, I like to deload or take a like a recovery week every 4 or 5 weeks. Some people can go like 6 or 7 weeks. Some people can only go like 3 weeks. And so the more you can train and the longer you can eat in a surplus without having to like step off the gas and hit the brakes a little bit, the better you're probably going to be in the long term. So I tell most of my physique athletes for sure, like we want to be in a surplus most of the time. Like, and so that way you're always feeling good, you're always training well. And then when we go to compete or we go to diet or maybe, you have an event like a wedding or something like that, like, yeah, you push hard and you diet. And then, but right after that, you're coming right back up to maintenance and you're going right back into a little bit of a surplus at least. So I think that's what people often miss. It's like they want to gain muscle and then they fail fat and they lose, and they go to diet, they lose fat. And it's this like cycle thing. And I feel like sometimes we just need to break the cycle and be okay either maintaining for a month or two or just going very slightly in a surplus, just like 100 calories.
Yeah, that's it. And I'm glad you bring that up because I think that again, a lot of people try to like rush that process. They try to make it go faster where it's like, I just, I want to build more muscle at one time. And it's like, I mean, you're again, like we had talked about your body, it's going to fight that as you get more muscle. So it's going to be tough to speed that process up. And it does really seem like there's a ton of the importance of momentum when it comes to building muscle. That's something that I try to preach clients is like you said there, like you want to try to spend as much time as you can in a surplus and like just not spending time out in a deficit because then that's going to hamper muscle growth even more. And it does just seem like there's a ton of it's just all about momentum almost when it comes to building muscle if you really want to maximize it. Dr. Mike Israel I was watching a video of his the other day and he had a funny saying. It's like when you're trying to, somebody stepping on the gas pedal as hard as they can and they're like they just keep freaking pushing it harder and harder, trying to make muscle growth go faster. And you just can't do it. And I thought that was a great analogy to it.
Yeah, no, that's a good one. Mike has some good analogies and good stories. Like sometimes you listen to him and you're like, man, you just make the science seem so simple.
So simple. And he's very good at making it interesting too, keeping people
Yeah,
interested, which is a big part of it, right? I mean, for some people, some of this stuff's super boring, but if you can make it interesting, that's great. We find it interesting, but some people are just like, what's going on?
yeah, for
Cool.
sure.
Yeah. Yeah. So, great sum of that article. Is there anything else that you would like to share on it or any other takeaways that you would like to leave the audience with it?
No, I don't think so. I think just don't, like you said, don't rush your muscle gain. Be in a moderate surplus. 200 calories is perfectly fine. And be patient. That's the take home from not just the study, but all of the bulking literature is just got to be patient.
Right. Again, you can try to make it go faster by eating more, but like you found in here, it's just going to add excess body fat, which, if you want to look your best, you're eventually going to have to spend more time in a deficit, which is going to hurt your muscle building long term. So cool. Great way to sum that up. I guess, so the next one is, and actually before we move on, and I'm assuming your study that you're doing right now with Eric Combs, that's going to hopefully give us some more insight into this as well.
Yeah, yeah. And I have no idea when that'll be done.
Okay. So once again, just be patient with it.
Yeah, for sure.
Cool. So we'll go over, we'll spend a little less time on this one, but another article you wrote was, do exercise induced increases in muscle size contribute to strength and resistance trained individuals? I think this is interesting. I think this is a pretty interesting topic. So if you don't mind just kind of going over what did the study look at, and then the findings, and then we'll just kind of see if there's anything we want to chat specifically about.
Yeah, yeah. So this is a study by a group out of, I think they're at Mississippi State. No, not Mississippi State, Mississippi, I think, Ole Miss. And so this group is of the kind of minimal effective dose type group where like we want to do the minimum, like the lowest amount we can to get the maximal output. In the output case, it's usually hypertrophy. So this study is kind of a follow-up, and what they're trying to figure out is, what's the difference between training a movement? So like we use deadlift. They use barbell curl, which is it's okay, but like a deadlift is probably more applicable. What's the difference between just practicing a deadlift and training, a couple times a week on the deadlift? And how do we tease out the kind of muscle component from the neural component? And so they did just a 8-week study where they had a group train a traditional 4x8 to 12 to failure, versus 1RM practice. So that would be the kind of learning effect. Uh, and they did it on the biceps. So they did bicep curls. It's kind of hard to do a 1RM bicep curl, but whatever. Uh, and they basically found that there wasn't much difference in strength at all over 8 weeks. Muscle thickness wise, the group that was training more traditionally, 4x8 to 12, gained a little bit more muscle via thickness. And then they also kind of had the back end of this study where so 0 to 8 weeks, you're either training traditionally, you're practicing. And then the next 4 weeks, you're either kind of doing a maintenance where you just train like a couple sets a week in the biceps, or just doing one RM practice per week. So basically they reduce the volume a whole bunch. Um, and they found that, muscle strength wise, people continued to actually gain a little bit of muscle strength. And muscle thickness wise or size wise, they kind of plateaued after that 8 weeks, which, makes sense. If you're doing minimal kind of training, you're not going to expect to grow a whole lot more. So they kind of try to use this data to say like, um, you know, muscle size and muscle strength are not really related. As I wrote this, I was just like, this group has done this a couple times, and it's not frustrating because it's good to have kind of different views of science, but it's hard to say that to a trainer or kind of translate that practice aspect of like, yeah, the big guy in the gym may not be the strongest, but he's definitely pretty dang strong compared to the rest of the people. So that was the takeaway, and it was a decent study, and ideally there is a large component that's neural, so that's just motor pattern learning, recruiting muscles. Like there's a large part of it, and then back in the 80s, late 70s, early 80s, there's a couple studies that figured like, hey, the first like 4 to 6 weeks of training is mostly neuromuscular changes where you're just learning things and recruiting more muscle.
Cool. Yeah. So it sounds like they almost they were trying to make it seem like muscle size does not mean that like you have a stronger muscle, or you're not stronger. Essentially, that's what they were trying to show with this study.
Yeah, definitely.
And I know you in the article you mentioned that that's probably not true. I mean, if somebody you take somebody who this to me, this would be geared more towards somebody who's like trying to compete in like powerlifting or something. Like if you're plateaued or something like that, what it sounds like to me is, you can only do so much if you're not like hypertrophying your muscles essentially.
Yeah, yeah. And there's a good article by Tabor. I think actually Cody Hahn's on it, and there's a really good statistician on it. And basically they looked at the kind of correlation between muscle size and muscle strength, because they're not exact. Like you see people in the gym, even just observing, who are like super jacked but then not that strong, right? They'll stand next to a powerlifter who's like, I don't know, 20 pounds lighter, and the powerlifter's doing way more weight. So there is some unexplained variation there, and it's likely due to the neural aspect. uh, but like you said, if you plateaued in your strength, the easiest way, or maybe not the easiest, but probably the most efficient way to increase strength is at some point to increase your muscle size. Now, with weight classes, that becomes really hard for powerlifters, right? Because if you're bumping up against that weight class, you're like, okay, I got to get leaner to gain more muscle, and then you got to diet, and you got to bulk, and all this stuff. Um, so it gets really, really hard. But in the grand scheme of things, like we know, once you're trained, muscle mass does relate to muscle strength quite a bit.
Yeah, and I wonder how much of that too is just, I'm sure some people just genetically are able to lift more weight than other people. Like they're just stronger, whether that be more like type 2 fibers, even though if you have type 2, is probably you're going to be bigger anyways. But I'm assuming that or I'm sure maybe the structure of their muscles too makes them able to lift more weight than somebody. Because yeah, I mean, you do see, I don't know. I see a lot of people that are like, oh, he lifts a lot of weight, so, but he's not very big. And I think a lot of people get confused as to why that is. But I'm assuming it probably is maybe they're just not doing enough, like you said, hyper, like general, like 8 to 12, like your regular hypertrophy range. They're probably just focused more on just like strength type training at that point almost.
Yeah, yeah, and that's why in the off season for powerlifters, because they compete a couple times a year, right? Well, maybe usually. You should probably take a couple blocks of training, 4 to 8 weeks, and just do hypertrophy work with sustaining their strength, of course. But that's kind of how you get around that in application. Now you mentioned something that a lot of people miss, and that's the 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 genetic underpinnings of how your muscles are connected to your bones, right, matters quite a bit. So if you think bodybuilders, you think Arnold, you think that big giant bicep peak. And that happens because his bicep is inserted farther up his arm, right? So it contracts farther and it gets just like this big bulge. So that's good for hypertrophy, for visualization. Uh, Now, if we go into a little bit of biomechanics here, um, if it was connected further down, the lever arm would be stronger, and so you can lift more, right? And so that's something that you look at powerlifters, and that where their muscles insert on their legs and on their arms can make a huge difference. And that you can't control that, like straight up. Like you can make your muscles bigger, but you can't change where they're inserted or where they start from.
Yeah, and I think a lot of people just try to chase weight, and they see certain guys do all this weight, and they're like, "Well, how come that guy can do it?" And it's like, well, again, there's all these things that play into it, and two, I mean, I think, and I'm sure, I feel like you probably agree with this. Lifting heavy like that is a skill as well. I mean, it's a skill. Like a lot of people don't realize that either. That's why when I see people do like random 1 rep maxes, I'm like, oh, you're kind of just shooting yourself in the foot there, because again, it's a skill, just like anything else. Um,
Yeah,
it,
definitely.
yeah, and so too, for athletes as well, I think, again, some people are scared of putting on like muscle because they're going to add weight or whatever. But I'm assuming too this can probably apply to potentially like athletes as well, that are like, maybe adding more muscle can improve their performance as well. Or
Yeah. So when you get to athletes, when you get out of the physique and powerlifting world, it gets a little tricky, because all you care about is how they perform, right? And so when we measure that in the lab, it's really hard to measure how like a football player is going to perform on the field, or a soccer player, or anybody really. And so there's that, like, how do we relate it to performance? Well, we can't. Well, so we kind of have to make some assumptions, and the assumptions are like Yeah, if you have a freshman coming into college, right, who's never weight trained, doing some weight training is going to benefit them, like straight up. But now, let's say they've been in the program 4 years, they've had good coaches, good strength and conditioning coaches, like good nutritionists, dietitians, they're on point, right? How much more is muscle really going to help them? Well, then we look at the transition of, okay, college athletes to professional athletes. And then you have a whole nother gap of like genetics and stuff like that to lay it on. But I really like to look at the basketball players because they're so long. Like when they put on muscle, you could tell. And so most of them are kind of weaker as they go into the pros. But then when you get, again, time under training with good coaches, doing the right things, and you're, of course, getting paid a lot helps a ton. But you see them doing better and better physically. Now that's still independent from their skills, but there is some component where like you need to be a certain level physically to perform like you know talent wise on the field on the court.
Yeah, I'm sure, the first thing I think of when I hear that is injury, right? I mean, you had talked about this in the last thing we talked about, to me, I feel like any injury is going to hurt your progress in building muscle, anything more than anything else, And so I think that I'm sure adding that size component to it is going to help with that as well, recovering and everything.
Yeah. So you're way more resistant to injury when you're trained because obviously, or hopefully, some of your training is proprioception. And so, you get a little bit of kind of dynamic movements and balance stuff work in there too, which helps.
Cool. Yeah. And so I guess what would be your biggest take home from this paper that you wrote?
Yeah. So I would say that, you know, up to a point, you can practice a movement and get stronger. But eventually, and that may be 12 weeks, it may be longer, um, you're going to have to, or you will likely have to, gain muscle to get stronger. Um, and it may not be that much muscle. Like it could be like half a kilo, half a pound of muscle may make a big difference because, we don't really know how much muscle specifically contributes to strength. We know it's about 70%, but once you get to the upper echelon, maybe it's way more. So we don't know that either. So yeah, that would be kind of the takeaway.
That's good. And I think that's good for a lot of people that are like, for example, maybe they're trying to increase their bench and they're just stuck and they just are like, oh, well, I'm not going to go any lighter because then I'm not going to get stronger. But it's like, well, you might need to drop the weight for a little bit, work in a more with higher training volumes to build more muscle. And then later on, it will help you uh, add weight to the bar. I think that's a great takeaway and probably something that a lot of people skip over. So cool. Well, Brandon, thank you so much for all the information today. A lot of good stuff. Is there anything, I guess, two questions for you before I let you go? Obviously, you kind of told us the study you're doing. Is there anything else coming up for you that you'd like to tell the audience? And then where can they find you as well?
Nah, so that's kind of I've pretty much covered everything that I'm even part of. I guess I didn't cover. So we're writing a ketone ester paper, but it's in animals and it's not really related to performance at all. It's kind of like just this one-off project that'll be pretty cool. Um, so yeah, that's pretty much all the studies. Um, you can find me on I think on Instagram is probably the best, most frequently posted content place that I'm at, just because I do like weekly series and stuff. Um, so I'm also on Facebook, of course, just type in Brandon Roberts. If you want to email me and ask me a question, occasionally I do podcasts. People have questions and they can reach out. You can find me at robertsb21@gmail.com. And then, if you have any specific things, you can DM me, and I probably have written something about it somewhere, either at Weightology, Examine, TCM's website. I got a couple things on Stronger by Science, all over the place.
Awesome. Yeah. So I will link that stuff in the show notes. Again, appreciate your time on a Saturday morning here coming on here. So appreciate it. And we'll talk to you soon.
Awesome. Thanks for having me, Jeff.
Thanks.